Okay, briefly, functions, what are they? Well, it's instructions on a single number to get you another number. So I tell you a number, and then you perform these list of instructions I've given you earlier, and you get another number. You're now a function. So what do I mean? I mean, in words, I can give you the instructions add 5 to the number. So the function that adds 5 to every number would take in 3 and give you out 8, for example. And in notation, rather than just words, we would write f of x is equal to x plus 5. So we read this f of x because this thing here, f bracket is the function itself. But a number goes in here. So we might write f of 3 is equal to 3 plus 5 is equal to 8. Another instruction we could give is multiply by 10. Now, f of a number is 10 times that number, so f of x is 10 times x. Okay, those are pretty straightforward instructions. We also get weirder instructions because the only requirement on a function is this. We can give pretty much any instruction we want. In this case, the instructions I want to talk about is find the positive value such that the square of the number find the positive value such that the square of the value is the given number. So if I give you 16, you find me a value whose square is 16, and that which is also positive. In that case, it's 4. And the reason I specify positive is because minus 4 squared is also equal to 16, and we only want one number out. If that point's confusing, think about it later, perhaps. But for now, again, just go over this one more time. Find the positive value, just so we don't get two values, such that the square of the value is the given number. If I give you 25, you tell me it's 5. And we've invented notation for that. It's f of x is equal to square root of x. And you can see why we use notation like this is because it saves us a lot of space, right? So what's the point of all this? Where does it go? Well, it goes, let's just write that down. Maybe take a moment, pause, go back, think about what I just said. Well, the point is, functions are the way of conceptualizing relationships between different things. For example, how much money you make depending how many customers come into your store one day, or how much fuel you use depending how fast your car goes. Something like that. So it gives you a relationship between values. And one way to represent a function is I tell you the value and what comes out for every value. So I could tell you 1, 2, 3, 4, and say I get this function's weird, gives me some weird like combination of things here. And there's obviously values between that. This might be something you collected and you might assume, okay, there's some weird function that fits all these values. What is it? How do I find that? Well, this is sort of where we might go in future videos. In future videos, we're going to look at how to graph functions. So that's kind of where this bit goes. So it's like, so we have these two sets of values. How do you represent that visually? Also, we want to talk about limits soon, which I'll motivate them when we get there. And domains definition, which is kind of a technicality of functions. It's kind of technicality because sometimes instructions don't make sense. Where don't they make sense? Why don't they make sense? That will be in the next video. Well, thanks for watching. That was functions in 4 minutes.